Hi, this is John Brito, Assistant Professor, Department of Mechanical Engineering, Hindustan College of Engineering and Technology. So today I'm going to discuss a very important and very interesting topic on vapor compression refrigeration system, which is nothing but how the refrigeration unit or an air conditioning unit in our household or in an industry works. So this is the objectives of today's presentation. First, I'm going to discuss about the introduction to refrigeration. Then, very important uh, thing, that is the laws of thermodynamics, which is the root or base for these refrigeration and air conditioning system. And finally, about vapor compression cycle. As I already said, so based on this cycle, the refrigeration or their air conditioning system will work. This is the cycle. See, so moving on. So what is refrigeration? Refrigeration is nothing but it is a process of removing heat from a place where it is not required and transferring that heat to a place where it makes a little difference. Which means, to make it simple, when we keep something in a refrigerator, in a fridge, what does it do? It removes the heat. Somehow it is doing something which we are going to discuss later. It is doing something and it removes the heat from that body, and it is taking out and it is dissipating it to the atmosphere, or to the environment, which we usually never feel. But once, since a room, a kitchen, or wherever we are placing the fridge is very big, so that we are not feeling the heat which is being dissipated. But once, when we are close to the fridge, maybe side wall or back side of the fridge, we may feel the heat. So what does it do? It removes heat from, maybe from veggies, or maybe some fruits, or maybe some meat, or some food we stack. It removes. Why does it remove? It removes to keep the products fresh. Normally the room temperature is around 70 degree Fahrenheit to 90 degree Fahrenheit, but inside the fridge it is around 35 degree Fahrenheit. Why so? To maintain the food fresh. So this is the refrigeration. This is all about the refrigeration. Simple. To make it, it's very simple. It removes heat and throwing it out. So before discussing about the vapor compression cycle, I would like to discuss about the three laws of thermodynamics, which is very important for uh, this refrigeration and air conditioning system. So first is zeroth law. As we know, when two bodies are in equilibrium, when we introduce a third body, that third body also will be in equilibrium with the other two bodies. So that is what zeroth law says. First law is law of conservation of energy. As we know, energy cannot be created nor be destroyed, but it can be changed from one form to other form. And very important for refrigeration and air conditioning is second law of thermodynamics. So two persons have given some input for the second law. One is Kelvin Planck, and one is Cauchy's statement. So what does Kelvin Planck say? It is impossible to construct an engine which convert the entire input into the equal amount of work. To make it simple, nothing is 100% efficient. Whatever we feed will not be converted completely into work. There will be some loss to the environment. So it is nothing but the vehicle, the engine, what we use in automobile. We feed with fuel, the fuel is not entirely converted into work. Some amount of input is been wasted. Second one is Cauchy statement. So what does he say? It is impossible to design a device which works on a cycle and produce no other effect other than heat transfer from cold body to hot body. To make it simple, heat cannot be transferred from cold body to hot body, but we know it can be transferred from hot body to cold body, but the other way it is impossible without an external work. That is what the Cauchy statements say. So the Cauchy statement is a foundation for this refrigeration and air conditioning system. It's a foundation. Okay, we need some external device to convert one form into other form, either from cold body to hot body or hot body to cold body. So this is a very important topic or very important cycle uh, which we need to know in order to understand the entire refrigeration and air conditioning units. This is the basic cycle. There are a number of cycles. Are there. This is a very basic and very important cycle. It is called as vapor compression cooling cycle. So this is how the refrigerator what we use works. So it mainly consists of the four components. One is the evaporator, second one is the compressor, third one is the condenser, and the fourth one is the expansion valve. This is in general. Okay. When we go for the real time, there will be n number of components will be added to the system. But this is in general. These are the main components. There are some sub-components. Okay. That sub-components are also equally important to make the system run. But this is the main components of the system. So evaporator, it is nothing but the freezer box what we have inside our refrigerator. Okay, this is the internal unit, and remaining three, the compressor, condenser and expansion valve will be the external unit. You know that will be kept behind the refrigerator or outside the refrigerator. Even in air coolers, air conditioning system, the internal unit is the evaporator. Okay, the external unit what we have will consist of this compressor, condenser and expansion valve. Fine. How does it work? How we obtain the required cooling inside the refrigerator? That is what we're going to discuss now. So I'll start from the left side of the evaporator. So there will be a tank, there will be a reservoir where the refrigerant will be kept. Maybe in the case of industries, we may use some cases they use water as a refrigerant. They use hydrofluorocarbons, that is R134A as a refrigerant, ammonia R717, R744 CO2 and R410A in the case of industries. But we as a household purpose we use normally we use R22 as the refrigerant. There are different types of refrigerant. So the refrigerant from the tank, it will be in the form of liquid. It enters the evaporator. That liquid refrigerant removes the heat from the evaporator. That is, we will be having some food, vegetables, food particles, food materials, vegetables, fruits, etc., meat, milk, whatever. It will remove the heat from that. The refrigerant will remove the heat. It comes out. Once it removes the heat, the liquid turns into gas. So it comes out as a gas. Here at this point it will be a saturated gas and a low pressure gas. So it enters the compressor. Why, you may ask, why compressor? What is the purpose of compressor? Yes, So see, in condenser, in order to make the condenser work 100% efficient, okay, the input may be of should be of high pressure. So in order to attain that high pressure, see here it comes out as a low pressure, but condenser works efficient only in high pressure. So this low pressure to be converted into high pressure, we are using compressor. So saturated gas, low pressure gas enters the compressor. Being compressed, you know, when it is compressed, pressure increases. So compressed comes out as the superheated. So as pressure increases, temperature also will increase. So it comes out as a high pressure gas, superheated gas. It enters the condenser, the condensation process takes place. When it comes out of the condenser, it is a hot liquid and high pressure liquid. Okay, the gas alone is converted into liquid, but temperature remains same, pressure remains same. And for that we use expansion valve. Once it enters the expansion valve, the pressure drops, the temperature drops, again it comes back to the initial stage. The refrigerant, liquid refrigerant around 5 to 6 degree. So this is how the entire refrigeration or air conditioning unit works. Thank you.